Hello Chem 1A, this is Chapter 4, Lecture Video 9, and this is our final lecture video for this chapter. We're going to be discussing a little bit more about redox reactions in this lecture video. Primarily, we talked a little bit about, at the very beginning of the last video, that oxidation means the loss of electrons. Now, we can also attribute that something in a redox reaction was oxidized by looking at the oxidation number and how it changes over the course of the reaction. If an oxidation number of a reactant increases, we say that that substance, that atom in that reactant has been oxidized. If the oxidation number gets smaller, we say that that atom in that reactant has been reduced. And this is primarily how we would determine what was oxidized and what was reduced in a redox reaction by looking at the oxidation numbers and how they're changing from the reactant side to the product side of a reaction. So let's look at a rather simple example. We have Zn solid reacting with H+, two of them, going to zinc 2+ and H2 gas. Now, we need to first determine our oxidation numbers for each of these things in this entire reaction. So I know that elements that are in their standard state and they're pure, like zinc solid, have oxidation numbers of 0. This guy has an oxidation number of 0. I also know that monoatomic ions, like H+, their oxidation number is their charge. So +1 for the H pluses. And the same thing is true of Zn2+. It's a monoatomic ion, so its charge is its oxidation number. Hydrogen is a diatomic element. That's the natural state of the pure element hydrogen, so this also has an oxidation number of 0. These numbers allow me to determine what was oxidized and what was reduced. We can see that the zinc here went from 0 to +2. This is an increase in its oxidation number, and therefore zinc was oxidized, right? Specifically, zinc solid was oxidized. At the same time, H+ went from +1 to 0. That is a smaller oxidation number, right? It decreased. This means that that hydrogen ion, H+, was reduced. Now, it's important to notice that oxidized and reduced are past tense, which means we're always referring to the reactants when we're asking what was oxidized, what was reduced. If you're asked either of those questions, know that it's always referring to the reactant side. Something on the reactant side was oxidized, something on the reactant side was reduced. We can determine which one by looking at both the reactants and the products in terms of their oxidation numbers, but at the end of the day, our answer is going to be one of the reactants was oxidized, one of the reactants was reduced. Okay, let's continue on. So let's look at a little bit this reaction again. There are two more vocab words that we need to kind of be aware of, and that is oxidizing agent and reducing agent. Now, this more than anything makes me think whoever comes up with the naming systems for chemists really doesn't like students, because this can get a little bit confusing. When we say that H+ was reduced, right? We talked about this in the last slide. That's true. But technically, it's also causing zinc solid to be oxidized. This makes H+ known as the oxidizing agent, right? So that sounds kind of weird. We know H+ was reduced, but it's also known as the oxidizing agent because it caused zinc to be oxidized. At the same time, zinc caused hydrogen ion to be reduced. While it was oxidized, we also call it the reducing agent. So this, like I said, can be a little bit confusing. Anytime you see this word agent, I want you to think exactly the opposite of the word that comes in front of it, because if we're talking about the reducing agent, that's the species that was oxidized. If we're talking about the oxidizing agent, that is the substance that was reduced. All right. So these two vocab words, you need to be able to basically determine what was oxidized in the reaction, what was reduced in the reaction, what's the oxidizing agent, what's the reducing agent. In all cases, we're referring to the reactant side of the reaction always, and whatever was oxidized is the reducing agent. Whatever was reduced is the oxidizing agent. So that hopefully helps. So let's determine this for the next two redox reactions. So we have this reaction here. This is a little bit more of a complicated example than the previous one. We need to figure out what was oxidized in this reaction and what was reduced, right? Well, that means I need to determine oxidation numbers of stuff. Right now, oxygen is throughout this entire reaction, and if you notice, it's always attached to something other than fluorine or oxygen itself. So oxygen's oxidation number in all these compounds is -2, and that's pretty normal. Oxygen is not usually the thing that's going to change oxidation numbers. So it's not the thing that's going to be oxidized or reduced. It's going to be something else. If we look at hydrogen, it's +1 here. In this water where it ends up, it's also +1. Again, hydrogen generally isn't the thing that's going to be oxidized or reduced. It can be, but it's pretty rare. So we're probably looking at the manganese and the sulfur in our reactions. Those are the species we want to determine the oxidation numbers for on both sides of the reaction arrow. So let's do that. So let's look at manganese here. We know that we have Mn's oxidation number plus -2 times 4 has to equal -1. This means manganese's oxidation number in this compound is 7+. Over here, it's a monoatomic ion, so manganese oxidation number is 2+. This is a decrease in its oxidation number, and this actually tells me that manganese in permanganate was reduced. At the same time, if we look at sulfur in sulfite, we have S's oxidation number plus -2 times 3 has to add up to -2. This tells me that sulfur's oxidation number in this compound must be 4+. Now, if we look at it over here, we have sulfur plus 4 times -2 has to equal -2. This tells me that sulfur's oxidation number over here is 6+. We went from 4+ to 6+. This was an increase in its oxidation number, so sulfur was oxidized. Cool. At the same time, we can talk about this next redox reaction. Again, the hydrogens and the oxygens, we're going to kind of leave those alone. We want to focus primarily on chromium and chloride are what we really want to focus on, right? So let's look at their oxidation numbers. So if we look at chlorine in this compound, we have Cl's oxidation number plus -2 for oxygen has to equal -1. Or sorry, -1. So basically, this tells me that Cl's oxidation number has to be +1 in this compound. On the other side, if we look at Cl over here, it's an element. It's in its standard state. Cl's oxidation number is 0 here. This is a decrease in its oxidation number, and therefore chlorine must be reducing, right? It's the species that was reduced. At the same time, if we look at chromium here, we have chromium plus 3 oxygen, so -2 times 3, plus hydrogen, which is +1 times 3. This all has to add up to 0. This tells me that chromium's oxidation number, if you add it all over, is going to be 3+ in this compound. Now, in chromate over here, we have Cr's oxidation number plus oxygen's times 4 has to equal -2. this tells me my chromium oxidation number has to be equal to +6. This is an increase in our oxidation number, and therefore chromium must have been oxidized. All right, so we could also ask, what is the reducing agent and what is the oxidizing agent, right? Well, we know that the reducing agent is the thing that was oxidized. So in our first reaction, that's going to be sulfite is our reducing agent, whereas the oxidizing agent is the thing that was reduced. So in this case, that's going to be permanganate. Now at the same time, in the bottom reaction, again, this hypochlorite was reduced, so it must be the oxidizing agent, and the chromium 3 hydroxide, it was oxidized, so it's going to be the reducing agent. Okay, if you guys have any questions, as always, please come talk to me in Zoom or email me. I'm always here for you guys for help if you need it.